Hello students, in this video we are going to study the chapter electricity basically for class 9 ICSE. So first of all, what is electricity? What is electric current? The rate of flow of charge is called current. If the electrons flow, then the flow of electron is called current. What happens in case of metallic conductor? The electrons are placed in haphazard manner. They are moving in haphazard manner from here in this direction until and unless we are applying something which will make them flow in a particular direction. Suppose if we are applying a voltage or potential difference, after applying this, what will happen? This greater one is called positive and the smaller one is called negative. After we apply the voltage, then what will happen? These electrons will start moving in the same direction. Okay, so the direction of electron will be from here to here, and the direction of flow of electricity will be from the positive terminal of the cell to the negative terminal of the cell. So if in a conductor the electrons flows, suppose from this to this direction, then the current flow in the direction opposite to that of the flow of the electrons. Now we will know about some terms, like when electron flows, that is called electric current. So what is current? Rate of flow of charge is called current. Okay, and what is the SI unit of current? The SI unit of current is ampere. What is the SI unit of current? Ampere. So what do you mean by 1 ampere of current? When 1 coulomb of charge flows to a conductor in 1 second, when 1 coulomb of charge flows to a conductor in 1 second, then the charge is said to be 1 ampere. Now when the current flows, when the current flows, there is obstruction given to the flow of current. This obstruction which is given to the flow of current is called resistance. Now the next thing is, what is resistance? So what is resistance? Resistance is the obstruction given to the flow of current. Okay, and its SI unit is ohm, denoted by this symbol. This symbol is called omega. Now, so what happens when current is flowing and resistance is being given? The current will become less. So, if you have to increase the resistance, then we can do something. What are the factors on which resistance of a conductor depends? It is directly proportional to the length of the wire. If you increase the length, the resistance will increase. Resistance is directly proportional to length of the wire. Resistance is inversely proportional to the area of cross section of the wire. Now, if a wire has cross section this, and if a wire has cross section this much, so in this case resistance will be more, and in this case the resistance will be less. Okay, so what is resistance? Basically, resistance is the obstruction given to the flow of current. It depends upon the wire. Now, which is the best conductor of electricity? The best conductor of electricity is silver. But why don't we use silver for making wires? Because it is expensive. So people use the second best conductor, which is copper. Now, why metals are good conductors? Question can be asked that why metals are good conductor? Because metals have free electrons in them. So metals have free electrons in them. So they are good conductor. While in case of insulators, there are no free electron, that's why they are not so good conductor. Now one more thing we have to know about this is voltage. What is voltage? Potential difference. What is potential difference? More is the potential difference, more will be the current. This was first told by Ohm. So that's why it is called Ohm's law. So what is Ohm's law? Ohm's law states that temperature remaining constant, the current flowing through a conductor is directly proportional to the potential difference across its ends. It means, suppose there is 20 voltage potential difference. Suppose in 20 voltage the current is coming 2 ampere. If the voltage is 200, the current will also become 20 ampere. If the voltage is 500, then again the current will become much more. It will be 50 ampere, like that. Okay, so more is the potential difference, more is the current. Now, what do you mean by potential at a point? Question can be asked. Potential at a point is defined as the amount of work done in moving a unit positive charge from infinity, from a very far of distance to a point. This is called potential difference. Okay, so potential at a point is defined as the amount of work done in moving a unit positive charge from infinity to that point. Okay, if 1 joule of work is done in moving 1 coulomb of charge from infinity to this point, to any given particular point, then it is called 1 volt. 1 volt is the unit of potential difference. Okay, now what is the charge of electron? It may be asked in question. So charge of electron is 1.6 into 10 to the power minus 19 coulomb. And how many electrons constitute 1 coulomb of charge? So that is 6.25 into 10 to the power 18 coulomb. Electron, sorry. This much electron will constitute 1 coulomb of charge. Now let us make ohmic conductor and non-ohmic conductor. So suppose this is voltage and this is current. This is ohmic conductor. It is following Ohm's law. It follows Ohm's law. Generally metals. Now this is non-ohmic conductor. Voltage is over here. Current is over here. This is non-ohmic conductor. So if they ask you to make diagram of an ohmic conductor, then we have to make this diagram. And if they ask you to make diagram of non-ohmic conductor, then we have to make the second diagram. Okay, now we should know about circuit. So what is a circuit? A circuit is the path through which a current flows. I am making a basic circuit. Suppose this is the positive terminal, this is the negative terminal. Current flows from the positive terminal, this is the resistance. Now there is the bulb, this bulb is called load, and then we can make a switch over here. Suppose this is closed switch. Okay. So now this is what? This is wire, conducting wire. This one is switch which is in on condition. This one is the resistance. Okay. Now this is the load, which is the bulb. In our case, if we use a tube light, that can maybe considered as the load. If we take around anything, like if we take music system which is running on electricity, then that music system will become load. Okay. So this, and what about this? This is called a cell, and a combination of cell, when many cells are taken together. Okay. Suppose we have taken 4 cells. Okay. We are going on taking some cells. Suppose 5 cells. Whatever cells, many combination of cells will make a battery first of all, and then there are 2 types of current that we need to know. One is DC. In this case, what is the direction of flow of electron? From here till here, and the bulb will glow since the circuit is closed. Now if the circuit is open from here, the bulb will not glow. So we have to make a conducting material in contact with it to make it a closed circuit. Now when current flows, the electron flows from here to here, and the current will flow from the direction opposite to the flow of electrons. If they ask what is the direction of flow of electrons, we can either say positive to negative. Another case, what is the direction of conventional flow of current? Then that case also we have to say the same thing, from positive to the negative terminal. Now we have to know there are 2 types of current. One is AC, another is DC. In this it is called DC because the magnitude of current is same, also the direction of flow of current is same. But what happens in case of AC? The direction of current goes on reversing. Okay, like this is the symbol of AC current. If this symbol comes, this symbol is a symbol for AC current. Okay, now DC current. Now DC current direction remains the same. AC current, alternating current. Alternating current, in case of that, direction remains changed. Okay, now we will know about cell. So there are 2 types of cells. Okay, primary and secondary. Primary cells are those cells which can be recharged, which cannot be recharged. It can be use and throw type of cell, like the cell that we use in our clock like wall clock. Okay. Now another is secondary cells. Secondary cells are those cells which can be recharged, okay, which can be reused, as for example the cell of the mobile, okay, lead acid accumulator, cell that is used in car, okay. So it can be reused. Why? Because the reaction in it is reversible, while in case of primary cell the reaction is irreversible. Here the reaction is irreversible. Okay. So basically what is Ohm's law? Now they may ask you that what are the limitations of Ohm's law. So in case of Ohm's law, what is Ohm's law? In case of Ohm's law, the temperature has to be constant. If the temperature is not constant, then Ohm's law will not be followed. So in case of Ohm's law, what is Ohm's law? So Ohm's law states that temperature remaining constant, temperature remaining constant, current flowing through a conductor, current flowing through conductor is directly proportional to the potential difference across its ends. Potential difference across its ends. Okay. Now what is the expression for Ohm's law? That is V equals to IR. Okay. Now if the resistance changes, okay, in certain cases we can change the resistance, like in case of fan. Suppose I have connected over here. It is shown by this. This is called jockey. So if the resistance changes, then this type of device in which resistance can be changed, resistance can be made variable or it can be changed, is called rheostat. Like we use in fan. So during the summer season, we use the fan at the maximum speed. But what happens during the winter season? We can switch on the fan, but at number 1 or 2. We just switch on the fan at the, like there are 5 divisions, so we'll switch on the fan at division either 1 or 2. Why? In order to get less amount of air. So in order to get less amount of current, less amount of air, what we do, we increase the resistance. Okay. And when the summer comes, we have to decrease the resistance. Then for decreasing the resistance, we just do the resistance very less. So that can be done by using the appliance called rheostat. Okay. Now I hope you understood this. Thanks for watching the video.